Have you ever wondered what really goes on underground at a gas station? This video will present an overview of how a fueling system works and looks at Franklin Fueling System's total system solution. In a fueling system, the environment surrounding the underground system may be very wet and experience extreme temperatures throughout the year that cause the ground to shift during freezing and thawing. Since much of the system is under a cement layer, it is not easy to quickly fix a component if something happens, which is why it is very important for underground equipment to be watertight so that leaks do not occur and risk polluting the environment. One of the major safety mechanisms in place is safe storage and removal of vapors from the tanks. Vapors naturally form when petroleum reacts with air or high temperatures, which create pressure. In order to fill up an underground storage tank, vapors need to be simultaneously removed while fuel is being delivered. When a tank truck arrives to deliver fuel, it will connect its hose to a tube that leads directly into an underground fuel storage tank. Once a customer pulls up to fill their vehicle at the dispenser, a pump in the tank will turn on and start pumping fuel through the pipes that lead up to the dispenser, then pass through the hose and nozzle and into the customer's tank. At Franklin Fueling Systems, we have 6 main product lines that make up our complete site package. Let's begin with piping and containment first. The main products we will cover in this category include our flexible and semi-rigid pipework, sumps, and our innovative watertight connection technologies that help move fuel safely from the tank to the dispenser. What is a sump? A sump is a containment in which water or other liquid is collected. In our system, a sump sits on top of a tank or under a dispenser to act as a barrier to the outside environment and house the connection points of the pipe to the pump so we can safely transport fuel from the tank sump to the dispenser. Our APT brand flexible pipework system can be installed in single long runs and move throughout the system without requiring joints to help it change directions while eliminating leak points. Our UPP brand semi-rigid pipework system is stiffer but utilizes electrofusion welding technology to create seamless joints. Essentially, the electrofusion welding process introduces a controlled amount of heat to join pipe and fittings together to create one cohesive and watertight system to transport fuel or vapor. When it comes to pipework, there are separate pipes for the movement of fuel and for vapors. Remember when I said an underground environment can be very wet? It is important that pipes have secure, watertight connections into tanks and sumps. Moving forward, service station hardware includes products that help safely manage the delivery of fuel into the tanks. When fuel is delivered to the underground tank, the fuel technician accesses the tank through the spill container. The technician then connects the delivery hose to the fill adapter inside the spill container. The fuel flows through the hose into the drop tube and into the underground storage tank. An overfill prevention valve monitors the level of fuel in the tank and utilizes a float shutoff mechanism to stop fuel delivery once the tank is at 95% volume to prevent an overfill of the tank. Furthermore, service station hardware also offers safe measures for vapor recovery. Our vapor recovery system features an accessible adapter for a separate hose to connect to safely draw out vapors from the underground storage tank. As for dispenser safety, if one is hit, the shear valve is designed to break in a controlled manner, and a poppet inside the valve will seal off the tank, protecting the product from endangering the customers and the surrounding environment. Now that we've discussed the safety measures involved in moving fuel, how does fuel actually get from the tank to the dispenser? The submersible pumping system product category includes the lpetrol brand submersible turbine pump. Our submersible turbine pump is a centrifugal design, which means that fuel is forced up through the pump by spinning impellers to create pressure and flow out the top of the submersible pump, known as the manifold. The manifold houses the electrical supply to the motor and also the pathway for the fuel to get to the pipe. As the fuel exits the submersible manifold, there is an interface for our mechanical line leak detector to monitor the fuel piping for leaks that could pollute the environment and cause downtime to the station owners, making for expensive cleanup. For every submersible pump, there are controllers that communicate with the dispenser to initiate power when it is time to move fuel. In the case of variable speed pumps, the controller also varies the impeller speed to provide consistent fueling equally during busy and slower fueling times. The variable speed controller can also communicate the pump status to run the station as efficiently as possible. Finishing up the underground systems, we have our wire management system. Electrical and data wires need to be installed safely and away from fuel lines. Our cable-type brand electrical conduit provides a true watertight end-to-end solution for electrical, sensor, and data wire management. A conduit is a channel or tube that protects electric wiring in the station environment. Franklin Fueling System's flexible conduit is constructed of high-density polyethylene, which means it is strong and flexible and can be used continuously throughout the fuel station and withstand more than conventional conduit. Again, we use the electrofusion welding installation process, like what we do with the UPP brand semi-rigid pipework, to join electrical conduit to each other and when entering the sump for a seamless and watertight connection. Fuel, on its journey to the vehicle's gas tank, must finally travel through dispensing systems products, or sometimes referred to as hanging hardware. These products include hoses, nozzles, breakaways, and in special situations where vapors are captured, vapor pumps. Fuel hoses are made of synthetic rubber materials and may also contain a wire mesh for added structure to support fuel from the dispenser to the nozzle and into the customer's vehicle. Our hoses are made capable of withstanding varying environmental conditions such as cold weather, marinas, and high levels of ethanol. Connected to the hoses are nozzles and breakaways. The nozzle is what the customer uses to dispense the fuel into their vehicle. Breakaways are for safety and put in place for those rare moments when someone forgets to take the nozzle out of their vehicle before they drive away. A breakaway, similar to a shear valve, will separate and shut off the flow of fuel to protect the dispenser and fuel from spilling on the ground. In the final stage of fuel, there is another vapor recovery element. Under the dispensers, there are vapor recovery pumps meant to pull dangerous vapors out of vehicles' tanks and prevent them from entering the atmosphere. Finally, Fuel Management Systems is the suite of products station owners and operators rely on to monitor and manage underground fuel tank levels, leak detection, and regulatory compliance requirements. Probes work with floats inside the underground storage tank to communicate the level of fuel and presence of water back to the automatic tank gauge. Sensors are placed inside containment areas and the place between the double layer of pipe and containment area called the interstitial space and communicate the presence of liquid where it's not supposed to be. Our Evo series brand of automatic tank gauges are the electronic consoles that reside in the back room of a fueling station. These devices are connected to probes and sensors throughout the system to relay vital data to the station owner. For users on the go, owners and operators can securely connect directly to their automatic tank gauge via any web-enabled device for centralized monitoring and data-driven decision-making.